So in this series of videos, we're going to look at stoichiometry examples involving mol-to-mol ratios. I hope this is helpful as you watch it. So if you get a question that's asking you to compare moles of two different compounds and you're given a chemical equation, that's something that's actually really simple to do. This is one of the simplest stoichiometry questions that you can possibly answer. So in this problem, let's take it step by step. The question's asking how many moles of O2, so that's what we want, are needed to react completely with 4.3 moles of carbon. So that's what we're given. And we're also given this equation, carbon plus O2 yields CO2. So let's quickly check and make sure that it's balanced. We've got one carbon on this side, and we've got one carbon on the product side, so the carbon is balanced. We've got two oxygens on the reactant side and two oxygens on the product side, so that is balanced. So this actually is balanced, and remember, if there's no number in front, and remember the numbers tell us the number of moles, then that number is 1. So I'm just going to write that in. Just as a reminder, all of those are the coefficient is 1, and the most important thing is that our coefficients tell us the number of moles needed for our chemical recipe here. So in this problem, we are comparing the moles of O2, which is 1, with the moles of carbon, which is also 1. Okay, so how can we use this information? So first up, you can completely solve this problem in your head, and if you want to pause, solve the problem, and then resume watching, feel free to do so. I'm going to show you how to do this in your head and also how to do it by drawing it out. I'm going to start by drawing it out. So we always start with what we know, and we know that there are 4.3 moles of carbon. Okay, and then the next thing to do is we're going to set up a ladder. Okay, what goes next in your ladder is the mol-mol ratio. And we get the mol-mol ratio. This is our recipe. And we get that recipe from the balanced chemical equation. So if this was like a recipe for hot dogs, we know that we need 1 hot dog plus 1 bun makes 1 complete hot dog and a bun, right? So we know that this is a count. That's a number. It's the same deal here. Mole is just a number, so we could just talk about this in terms of numbers. So 1 piece of carbon, 1 number of carbon, plus 1 number of oxygen gives us 1 CO2, just the same as our hot dog example here. So these are our numbers there, and these could also be the number of moles. We could have 1 mole of hot dogs, and then we would need 1 mole of buns, and that would make us 1 complete mole of our hot dog sandwiches. So it's the same deal here. So that's why this is our recipe. This tells us if we have this much ingredient, how much of this other ingredient do we need, or how much can we make? Okay, so we are starting with more than 1. We're starting with 4.3. So how much oxygen are we going to need? If we had 4.3 hot dogs, we know that we would need 4.3 buns because these are in a 1-to-1 molar ratio. And so I'm going to show you what that looks like in the ladder using these numbers right here. We know that we need 1 mole of carbon, and that's on the bottom so that it cancels, and that we'll also need 1 mole of oxygen. Okay, and then this tells us now our units are moles of oxygen. That's exactly the units that we want, and we are done. So if you did this in your head, you recognize that these are in a 1-to-1 ratio. You did this in your head. There's no real math needed, because if you multiply by 1 and divide by 1, the answer is still 1. Okay, so that example was kind of easy, even though we started with something that wasn't a whole number. The mol-to-mol ratio was really simple, and that was just to warm you up to the idea of mol ratios, that this is the recipe. This is the only way that we can compare two different things. If someone gave you 12 pounds of hot dogs, how many hot dog buns would you need? That is not a question that you can answer in your head because you have to figure out, well, how many hot dogs is that? So anytime you're given a mass, anytime you're given a weight, you have to get it to a number. And that number in chemistry is moles. So always get it to moles. If you're given grams, get it to moles. Okay, so here's another problem where we're not using a 1-to-1 molar ratio. So how many moles of KCl, that's what we want, would be made if 9 moles of oxygen are produced? So we're saying in this recipe, where the numbers in front mean the number of moles, 2 moles of potassium chlorate, KClO3, will break down to make 2 moles of potassium chloride and 3 moles of oxygen. So if we made 9 moles of oxygen, how many moles of KCl were also made? So go ahead, pause the video, answer this for yourself, and then resume the video. Okay, so this is another example where if you recognize the relationship between 3 and 9, so in the recipe, we know we have 3 pieces of O2. In our problem, we're looking at 9 pieces of O2. So if you can see that, oh, this is just tripled, I tripled my recipe, then you know that you would also triple the amount of potassium chlorate, and you would also triple the amount of potassium chloride. So if you triple the amount of potassium chloride, we know without even having to do that much math on the paper, we know we would end up with 6 moles of KCl. We know that that's the answer because the oxygen has been tripled. If we tripled 2, that's 6. So that's one way to do it. And let's talk about the other way to do it, and that's by writing the whole thing out using the ladder. The ladder will never steer you wrong. So we start with what we know. We know we have 9 moles of O2. We want moles of a different compound. Anytime we're looking at moles of a different compound, we're going to use the mol-mol ratio, and that's from our chemical recipe. So here we know that we're comparing KCl and O2, so we're going to look at these numbers. Remembering that these mean moles, we know that if we have 3 moles of O2, we will make 2 moles of KCl. So this is now exactly what we want. Moles of O2 cancel top and bottom. Those units are exactly the same. They cancel. 9 times 2 is 18 over 3 is going to give us 6, and the units that we're left with are moles of KCl. So you can see if you do it with the ladder, you get the same answer as if you do it in your head by recognizing this relationship. So if you don't see the relationship, if it's not like blazingly obvious that these two things, moles of O2 and this moles of O2 are, if you don't see that number relationship, you can always do a ladder and you will always get the correct answer.